Yeah, hi everyone. I'm Yukang Yan, an assistant professor in computer science at University of Rochester, and thank you for joining us today for the Voice of XR and Marianne Mavrinek Studio X speaker series. And this series is made possible by Kathy McMorrow Murray and the National Science Foundation as part of the interdisciplinary graduate training in science, technology, and applications of augmented and virtual reality at the University of Rochester. It's really my pleasure to introduce our speaker, Dr. Michael Nebeling, today for the talk on three wishes for the future of AR. Michael is an associate professor at University of Michigan in Information School, leading Michigan Information Interaction Lab. I will leave for him to introduce more about his research, but I just want to mention he's among a few guys who let me know that being a professor could be an interesting and fun job, but that's not all the fact. Okay. So today I'm also serving as the moderator. So if you, for folks on Zoom, please feel free to post your questions in the chat. So we'll have a Q&A session by the end. And last, this session is actually being recorded and will be available to you later on Studio X website. All right, take it.
All right, thank you. Thanks everyone for inviting me here. I mean, there were a number of reasons I really wanted to come. One is I wanted to see how Yukang is doing, and he visited my lab, and then the pandemic started, and it was a bit of a sad end to our collaboration, I think. Of course, it's nice to see how you guys are all doing. It was very interesting to learn about all the things you're doing in this space. There's a little bit of competition going on because Michigan also wants to be really active in this space. And so I had really nice conversations today. It is also probably my first time since I actually visit a place since the pandemic. I'm not sure how many of you rolled back on travel, and so I must say I really missed it. Like meeting all of you, the young talent, it's really cool. So quick background to this talk. I knew I wanted to have three wishes, but I didn't know what those three wishes were, and so I was experimenting with these three wishes. But I was also asked to just tell you a little bit more about myself. So we'll do this first, and then I'll jump into what I kind of like from a bit inspired by the Make-A-Wish Foundation. It's not as nice as their logo, but I didn't want to steal it. But we have this idea of today we can wish some things for the future. So my interests are primarily in augmented reality. I see a lot of everyday interesting applications in this space. I've also done some work in virtual reality. But so I'll start quickly. So how I got interested in XR was the question I got. This is a picture of me from, I think, 1 or 2 years ago. I was experimenting with the Meta Ray-Bans at Meta. So I was on sabbatical at Meta. And it seems like it's like the play. Some people might think, I mean, under the current conditions, maybe that is not true anymore. And I don't say it nearly half as proudly as I did before, but it was an interesting experience to visit Meta and spend a sabbatical there. So imagine like for a year, they take you in and they allow you to learn about their plans, their 10-year plans, both in product and in research. And suddenly this industry environment that always seems opaque to me became transparent by them allowing me to join them and learn about their work. And that. So definitely very, very cool. So I'm not sure what your first interaction with computers is, but for me, it was my first programming language was Turbo Pascal. I was a big fan. It had object orientation. It was cool. When I became a PhD student at ETH Zurich, I actually met Niklaus Wirth, and that was one of the coolest things. It was a dinner experience. My PhD advisor introduced me to Niklaus Wirth, and I'm like, oh, this is Niklaus Wirth. He invented Pascal. And she said to him, this is my latest recruit. He's from Germany. I was like, okay, good luck. He's Swiss. It was very nice. It was just very cool. So I want to tell you this. And then I didn't know for a long time. There are many veterans in the space. Like I'm sure many of the speakers you've had here have been more experienced, more established in this space. So I've been doing it since 2016, 17, right when I started Michigan. This is a picture of me at ETH Zurich, where I did my PhD, and postdoc. I spent a little bit of time afterwards. And I was always interested in interactive technologies. And like here we designed actually a web browser that you can control from your couch using Kinect and gesture-based interaction, and basically your hands become like cursors. And so it was kind of like cool. It's not exactly augmented reality, but it started to feel like I want the environment to interact more with me, and more seamless interaction, I think, was definitely one of the things I was interested in. So when I joined at Michigan, I thought I'd show you my office. It looks way worse now than it is. I actually have a whole cart of AR VR devices that will all go to the cemetery now because their time has passed. Many of them were Windows mixed reality devices that Microsoft kindly donated to us, but they are just like useless at this point. You can actually see one there. If you know this ugly Acer Blue, you will know this is the Windows mixed reality headset from the around 2018 era. This was also the time when I really developed my passion for live streaming. In fact, my office hours were on Twitch. I had people join from all over the world, including Australia. And so it was like this. I would have really funny, everything that could go wrong did go wrong in my office hours. I was explaining assignments. I had like this wobbly hamster walking around, and unfortunately, we looked inside the hamster. It didn't look very nice inside that hamster. They didn't really model it, and so model it well, and so it became very creepy. But it was fun, so I just was experimenting with new methods, and I think this also then made me develop this passion for online teaching. So I did the XR MOOC, so it's like 3 courses online. Maybe 30,000 students have somehow been enrolled. I don't know how many have completed, and I receive messages on LinkedIn. And it's not often that as a professor you receive gratitude from your students. I think this happens more outside the university than inside the university. I don't remember many students coming to me after class and thanking me for this lecture today, but it feels like, oh, it's kind of nice. It's nice. So I was experimenting a lot with. So it was 2018, I think. So hang on, 2016, 17. So 17 was an interesting year. If you remember, ARKit came out. It was not there. And then slightly later was AR Core. And these are both the mobile AR platforms that they were markerless. So they were actually really interesting. Before that, many, many years ago, 1999, we actually had a system called AR Toolkit. It was developed by a friend and his PhD student, so Mark Billinghurst, and his PhD student, I don't know the full name, but the first name of the PhD student is Hero. And that's why we have a Hero marker. And this is a marker here, a fiducial, that is tracked by a camera. And in this case, I'm showing a solar system, and I had like it animating, and it's just cool. I like bringing these tiny things to life in front of you. And it also got my interest in the applications of AR to teaching and instruction, with my limited mindset, because I'm not an educator per se. I have a teaching obligation, but I'm a researcher by design, I think. I experimented a lot with what I think is a sad thing. A lot of Google technologies were actually really, really powerful. There was Google Cardboard, there's Daydream, which you see here. It was actually relatively high quality, 360, 3 degrees of freedom experience, and you put your smartphone in there and you have a headset. And then when these things that get discontinued, especially Google Expeditions, for example, allowed you to explore a lot of interesting content. You could go to a museum in VR. You could have classroom expeditions in VR. I got really excited about all this stuff. In fact, I wrote an NSF proposal where my vision for the future of AR at that time was that we won't have dedicated headsets. We will extend the smartphone to become a VR or an AR headset when we need it. And the reviewers didn't believe me. I think it got rejected, and Google discontinued most of their programs, unfortunately. I was experimenting a lot with physical prototyping. I'm a strong believer I teach interaction design. I taught interaction design in the beginning, and then the department allowed me to develop my own AR VR courses. It's just nice to get that freedom to teach the courses that you're passionate about. And I experimented a lot with rapid prototyping using paper transparency for viewfinding, and simulating a visual field of view within a headset using accurate angular projection. You don't see all that detail, but it's basically a 360 template on the left. This entire mountainscape would wrap around the user's head. It's a 360, so panoramic kind of view. It's called accurate angular projection. And then when you take a photo of this and we develop software for it, it becomes immediately a prototype that we can actually live stream to a phone. And anyway, so I want to tell you, so I got excited about HoloLens. I don't know what it is for you that is your first AR VR experience or your best AR VR experience. So HoloLens 1, sorry, which had this interesting nose piece, and it actually exerted a lot of weight on your nose. You look like somebody hit you after you used this device for a little bit. But it's just cool. It was, from an interface perspective, it was Windows applied to AR, which is actually a paper from the 90s by Steven Feinberg. And so it took 2015, took 25 years to make it actually a Windows product. Windows into the world, kind of, I think was what the paper was called. It has spatial understanding, many of you will know. It has a very simple interaction concept. You use your head gaze to point. It doesn't have eye gaze, but that white cursor is essentially where your head gaze hits the surface that was detected. You use air tap as a gesture, which is very easy to recognize, relatively easy to learn, and becomes your primary interaction modality. And it has all these issues that many of you probably study on the perceptual side, including how computer vision could work with glasses and black surfaces. Is it a shadow, or is it actually a surface? So there's interesting challenges there, but it's a cool experience, and I really started working with this. The university where we are started to invest a little bit more into infrastructure. We have like 22 workstations with Quest Pro equipped. At this point, it was Rift S, so I took, actually just a Rift, I think. Might be, I think I see the Oculus trackers. So just Rift at this point, but like we have Quest Pros now. I teach in this environment my courses, try to be hands-on, and I'll show you some examples today as well. Let's go to my lab. This is a little bit of photo manipulation here. The left is the real photo from my lab. The right is like, it's a little bit further to the right, but I just wanted to make sure that you are mentioned in this talk. This was when Yukong was visiting. He spent a lot of time in there. In fact, we set up a ping pong kind of like table set, and we played and discussed research ideas. I really enjoyed that. So some of you may have seen this video. It is from my online courses. What I try to do in the course is also to use the technology for teaching. So this is a mixed reality capture of me where I'm trying to go through Milgram's reality, virtual reality continuum and try to explain how the different concepts of mixed reality, augmented virtual reality, and virtual reality, how they relate to each other, and then also establish the term XR, where I think all I do is just like sketch around and make it like a really kind of like, this is everything here is XR. And the way I use these terms also has changed. Many of us, I guess Voices of XR is what you called it. If you had called it Voices of MR, it would actually create quite a bit of confusion. Some people don't know whether virtual reality is part of mixed reality and cannot agree on this, but it's interesting. So anyway, the reality virtual reality continuum, I think many of us show this. You've probably seen it 100 times in the last few years, because we still, as an academic established in 1994 by Paul Milgram from the University of Toronto, you feel like this is it's a good way to think about this space. So we just saw a video. This was Michael standing in front of a green screen. You wouldn't need a green screen anymore. We can do people segmentation live now on even an iPad. But we used the green screen at the time. Then what Michael actually experienced is what you see here on the right. So this is like actually what I saw in the headset. And then we create this composition where we essentially put Michael in this virtual world. And we don't call it a virtual reality. We would technically call it a mixed reality capture, because the camera receives a live stream, which is a composition of both the virtual world and the real world. And so you're like really right in the middle of what I would call mixed reality capture. So this was also a little bit the terms. I feel like you guys are all experts, but I will talk mostly about augmented reality. I do not use the term mixed reality much. I think like, I don't know, people do all kinds of things with these terms. So for example, like 1 or 2 years ago, Google started talking to me about immersive AR, and I wasn't sure what that is, because immersion is not necessarily a concept I immediately associate with AR. It's more like something I associate with virtual reality. But they meant video pass-through devices. The idea that you create an AR experience through a video pass-through device. And they call it immersive because VR headset is immersive. And so it's interesting. So I want to think with you about the future of AR. I must say, I have some specific ideas that I have developed while at Meta, but I also signed various agreements at Meta that I do not recall. So I will share it a little bit more abstract, and I wish sometimes I could go into a little bit more detail, but like, let's do it very quickly. So this is HoloLens. You do an interaction, you see the smiley user. What is the main problem of some of these devices? AR devices have a very small field of view. Yeah, in fact, it would cut off the content. Many of you have experienced this. It feels like it's really hard to render large objects in an AR experience. And then when you cannot do this, it just breaks, I guess, the illusion. I wouldn't say it breaks immersion. It breaks the illusion of this object being part of reality. They have limited battery. In fact, most devices that I know, like the HoloLens, for example, has about 3 hours of battery under use. They're heavy. In fact, the HoloLens 1 was 579 and the HoloLens 2 was 556. Like it saved 23 grams, like nothing. It could do a lot more. The HoloLens 2 could do a lot more, but like many of these. So what are actually desirable properties? And I think some of you here have an optics background and will probably even feel like, Michael, this is not completely correct. But the human visual field, as far as I understand, what we can address with binocular vision is around 120 degrees. So in fact, the Quest 3 is praised as the device that has a larger field of view as than the Apple Vision Pro. Apple Vision Pro now discontinued, had 110, according to what some people say online. And then, of course, beyond binocular, you also have 50 degrees on each side that you can only see with one eye at a time. You cannot actually see it with both times. I'm very interested in peripheral vision, so I'll tell you a little bit more about this. A full phone battery charge. Mine is about to die, I think. It doesn't even last a day anymore. It also depends on what kinds of apps you use. But we have an expectation that when I buy a future of AR glasses, I don't want to just use it for 3 hours a day. I want to somehow we need to sustain. We need to, as designers and developers and engineers, to our users, we want to provide an always-on user experience, which means the device is probably always on the head. It may not always be technically on, because we probably also want to deal with privacy and security. If we want to get it right, we should actually really have investments in that space. And some of my research is in that space. But for example, is something I couldn't really do while I was within Meta Reality Labs research, because at least the environments in which I interacted with, they were not really experts in privacy and security. So I don't want to say Facebook doesn't know anything about privacy and security. Maybe there's a little bit of that in that statement, but it's just like not where I was. And the typical weight of glasses. So I looked this up, and some people I know are very sensitive to the weight of glasses. So the Ray-Ban, which I guess many of you know what it is. Yeah, so this is you can buy this as Ray-Ban. So it makes a difference, right? So I think they will be on when I put them on my head. I have just normal Ray-Ban. This is Meta Ray-Ban. You can see the frame is kind of like bigger. Obviously, it has cameras, and many of you have probably played with these, even though it's more like a consumer device. It's not useful for research at this point because it doesn't have an API. It weighs what does it say? 48 grams with it doesn't have a display, it doesn't have a visual display, it has speakers, but that's it. Like it's 48 grams. And then the Wayfarer, I think I have a different model here, but the Wayfarer, which this is based on, without the Meta contribution, is actually 44 grams. So it is impressive that we can create smart glasses that weigh 4 to 5 grams more and have all this advanced technology in there. And maybe some of you know the stats a little bit better. So this is maybe not official information. This is something I found out as I was like experimenting and looking around online. So I think it is very interesting to think about how can we. So the HoloLens 2 has a lot of advantages. It has binocular rendering. It has binocular eye tracking. It has world lock rendering, which means we can actually create an AR experience. It has a small field of view, but it is more advanced, I believe, than any other glasses you can buy on the market right now. And maybe somebody would disagree, but like, yeah. So how do we get from, and now people try to create AR experiences through video pass-through. So this is my artistic representation of something that looks like a Quest headset. And so our goal is to actually create something like this over the next few years. And there are many vendors in the space right now. So what do we need to pack into these glasses? I think many users well, I'm actually not sure how many users would actually expect a visual display, but if you tell them it's AR glasses, it would have to have a visual display. Otherwise, you would just call it smart glasses or wearable AI. It's going to have a lot of cameras in there, maybe some predominant outward-facing cameras. Maybe you can get away with one. I think the Ray-Ban, I should have looked this up, but it has two. Does anybody know how many cameras an Apple Vision Pro has? 12. Can you imagine? The Meta Orion has 7 cameras. Do we feel good about this? So it's interesting to think about it. And then, yeah, limited or no visual display, maybe. I think there is a trend to improve the sensing rather than the visual display capabilities. The visual display capabilities are actually often more expensive to power with battery. And if you have good sensing, maybe you can identify opportunities when it is okay to turn on or off a display. So I want you to do this exercise. Due to my limited graphical abilities, what we're looking at is a person with a really big head, like Michael, and the glasses in front of them. And I was trying to sketch out the visual field. And one thing that I'm personally very interested in is a concept that I have developed, and hopefully there will be more publications coming out in this space, but I don't have a lot of it published at this point. We have internal things, but nothing external. So this is supposed to be the foveal area. I think I drew it a little bit larger, but basically you have 5 degrees of your visual field is actually what you see at the highest resolution with the best color perception. And it's really what we call central foveal, maybe, yeah. So the macular area. And it is interesting. I don't believe in a future where everything that I look at will shine at me and I have little fairy tale figures come out. I don't know, this is what gamers think, but this is not how I think about the future of AR. And I also want to think about, so I don't want it always to be in the way. And I also I want to move it out of the foveal area. So I want to move it in peripheral vision. And I want us to think about displays that can actually address the entire visual field. I know it's very hard for us to create these, but maybe it's easier if it's monocular. And actually support like interactions like this, where you have like more like an assistive low power AR mode that maybe shows you more like a notification style display, similar to a lock screen on a phone. And then when the user actually decides as they target objects in the world and want to address some of the information around them and really interact with the content in AR, then maybe we will be able to go into like a full-on AR that is maybe more in the center vision. I don't think that we will be able to address the entire glasses like the way I render it here. I'm going to show this one more time. I think the colors are not as great that I chose, but I wanted to illustrate now we're using monocular at least. I think many people would still disagree that monocular is actually powerful, but to be honest, I have created several monocular AR displays, simulated them. You might say, Michael, you haven't really experienced it, but it would be under real optical conditions, and that's why I was so excited to learn from you today. But simulating then in VR is very interesting. You actually only realize that it's monocular when you close one eye. Most of the time, it seems like your eyes are just like really, they're just filling in. At least in the VR headset. So I'm curious how you would think about some of these things. I do think monocular AR can be very powerful. I do not feel discouraged by the fact that Google Glass has failed. I think one of the issues was that it rendered things in peripheral vision and it required that you actually had to fovea towards it. It creates very socially awkward movements. And it just really removes your attention from what matters in the world. And so what I'm exploring, for example, in the current master thesis is how we can, for example, render objects in the world that the user is gazing at, and how do we best represent them in the peripheral vision. So we know, for example, that shape is very important and color is very important, but color perception also changes when you're on the peripheral view. And so we're developing algorithms right now to locally optimize when you look at a bunch of objects to highlight the color in different ways, increase saturation, not under realistic battery and power and display constraints, but like in a VR simulation. And I'm just having a lot of fun right now to explore what this future of AR could look like. So this is the pitch for the future of AR. I'm going to tell you what my 3 wishes are. So are you ready? Maybe you should think about what you would want. I think some of you would feel that my wishes are incomplete. For example, I think they're incomplete. For example, so I have one that is about safety, and what I mean by that is physical safety, ethical safety, and things like that. And I care a lot about this, but I just had 3 wishes, so we had to make it work. So the first thing I'm going to say, and this is interesting, when I joined Meta for the sabbatical, I was, you don't know you don't know who you are and you don't know where you are. So I remember I was saying that I do not believe in virtual reality. It has to be more tangible and more realistic, and that we have to develop gloves and all that shit. I said I do not believe in this, and then I realized later that the boss of my boss of my boss is actually really into gloves, and so so don't feel offended if I don't believe in your future. This is mine. So first of all, my goal will never be to make things as realistic as possible. This is what NVIDIA wants to do. Photorealism is a big thing, but I don't think it's useful. In fact, we have done studies where we imagine you're doing a brainstorming and affinity diagramming task, and you do it in two environments. In one, we show you like a really realistic office environment, and in the other, it's just like empty space. Do you think that in a collaborative scenario where you collaborate around a diagram, do you think that the realism of the environment actually has an impact on how well you perform in the task? Well, there was no such effect for us, but it also lacked physics simulation. We were doing this in spatial, so the nodes were just like hanging around. But I just don't believe in I just believe in Einstein. And Einstein said, make it as simple as you can, just not simpler. And so that's what we're going to do. So if you are in computer graphics and computer vision, please challenge me. But I think, especially for the problem that I'm currently trying to solve, peripheral vision, I don't need the highest sophisticated 3D reconstruction. I can probably get away with some Gaussian splatting techniques or like some simpler volumetric representations. I could probably also need more like geometric approximation, more like shape-fitting algorithms rather than realistic reconstruction. So maybe some of that is just driven by this current vision that I have for really making peripheral vision also part of the formula. My second wish is make it about the user, not the reality. There's this, coming back to the glove, I think that we call it augmented reality because it is driven by this dream to make content align and interact with the real world as if it were part of the real world. And it is really, an interesting goal to have because you can measure it. You can compare it to what reality feels like. But I think we should really, the talk I want to give one day, but I'm not there yet, is AR as an accessibility problem. But what I don't mean by that is like enabling people, like using AR as a solution to enable blind and low vision. No, I really fundamentally want us to think about the problem is that we cannot perceive the virtual content around us. Like blind users cannot perceive or only perceive a subset of the physical world. And with that mindset, what kind of solutions would you create? And it becomes more about assisting the user and not about dressing up the reality. And so that's my wish. Hopefully we do this. And then my last one, because it's always a good wish to have, and there's so many interesting compromises that you need to take, is to make it safe for both users and non-users. And it's actually, I think it will be easier for us to make it safer for users than for non-users, because we can obviously track users. We're currently working on an interesting project with my PhD student, Shweta Rajaram, and a collaborator at Michigan, Jesse Chen. We're working on a project where we're trying to explore how could we actually make it fair, kind of like an equilibrium. How could we achieve an equilibrium when we all, or maybe not all of us, wear AR glasses? And imagine we all capture each other. When you think about the future of AR and what happens in my class, often my students sketch out experiences. What I notice is that there's only one person who wears AR glasses. Everyone else lives in the past. They haven't adapted or adopted. And I just think that's not true, because potentially it will actually find widespread adoption. And we really need to think about how can we make it fair. And so it's easy to track what users do. So for if Yukang and I both wear glasses, which we do right now, and imagine they have sensing, we could, for example, reduce the sensing range if we detect we're looking at each other. But if I cannot track you or don't know how far you are away, I would have to use this information that's captured by me. I'm already violating your privacy by just doing that. It is just interesting. So I think it would be cool if we would still have the option. But in many ways, it's like My professor, when I was a PhD student, she never wanted to create a Google account. She never wanted to have a Gmail. And so you never want to buy these AR glasses. And then everybody has Gmail and Google and tells you how good it is. Maybe everybody will have to be forced to adopt at some point when you start not receiving information or not seeing this beautiful AR world. So maybe we won't have non-users, but I think we've learned anything from the past, it should be a choice, and so there will be non-users. So what I do now, unless you want to challenge me on my vision, yeah, you could actually challenge me on my vision, and I think we would have a productive discussion. But I'll tell you what else I have in mind is I wanted the rest of the talk is actually more like showing what I've been trying to do towards this vision, but that's it. But otherwise, I think it could be very interesting, especially if you have your own wishes or if you want to push back on anything I've said so far, this would actually be a good time if you wanted to.
Anyone? I can go first. So about the
He's
first...
been waiting for this. Let me get something to drink. Hang on, I'm going to go into my punch bag mode. No, yeah, go ahead.
I mean, like, let's get back to your example, right? If we are doing brainstorming, we are saying whether to choose from a physical office and an empty virtual room.
Yeah.
But what if we can have a physical virtual room?
Oh, I think reality always beats virtual reality. But what is your question? Sorry, I answered to it.
I mean, if we can let the people feel like they are immersed in a different room virtually as a physical virtual room, that's a different type of realistic. It's not realistic to the current physical environment they're in, but that might be the best for their task performance. It doesn't need to be simple or realistic. It's kind of like a task dependent thing.
Okay. But would you, how much?
Like, for example, if I can visually remove all the distractions
in this room,
how do you think whether that's better than the virtual room?
Well, I still think it's tangible because I would actually be able, if I perceive depth still, if you do not remove the walls, if you manipulate it in a way that it's actually just without, I mean, to be honest, I mean, it's a very interesting environment for like first time here and like, when you go to your colleague's office for the first time and you study everything and you these are all the images. And this is a very interesting environment. But to be honest, I don't actually have enough time to process this. And there are people with other kinds of, like maybe this is overstimulating to some people, to be honest. Like there's a lot of color in this room and the light is interesting and interesting reflections in this window over there. And like, so I care a lot about how we could manipulate the environment to actually, for example, include more users along the neurodivergent spectrum. But, well, I don't know. So my point was to not aim for photorealism. And if we don't do this, we will probably achieve a lot of things. We can keep the experiences safer, more simpler, safer, more task focused, and we will save battery because therefore support longer usage. Yeah. But it's interesting. Anything else you wanted to discuss?
Yeah. Anything from the audience? My question would be challenging, so I will give.
Yeah, I don't find it particularly challenging. I think it's just interesting to discuss. There are different trade-offs. Yeah.
I mean, by simple, are you thinking about the rendering part or like I mean, there might be something very complicated to render, but it seems simple to the user on the perception
side. Yeah.
Are you talking
I think it would be interesting to unpack this a little bit more. I haven't actually. So I wanted to look for a word that creates an interesting contrast to realism. And I strongly believe it's also like the same thing with immersion and presence, right? First of all, many people confuse these two concepts. They look at a scene, it's photorealistic, and they say it's so immersive. It's not. It may create presence, but it's not immersive unless we stimulate more than your visual senses. It would be more immersive if you stimulated my haptic senses, my audio senses. Then you would talk about immersion. Otherwise, you would just talk about place illusion and maybe a little bit of place plausibility, according to Mel Slater. And you would call this presence. But I think, like, in many ways, we still I can keep iterating on my word simple. But I was looking for a contrast to realistic.
We have one
question online.
Question online, yeah. Do we allow them to speak up or they can only type?
Yeah, we could try it. We might be having a Zoom issue.
Yeah. Could you speak up for the question, or you can also type in the chat channel? Can you hear us? Yeah.
I'm sorry, are you talking to me?
Yeah, we can hear you.
I had a thought and a question. The thought is that when I watch cartoons, and some of those cartoons have gotten very realistic, I can get immersed in a very simple cartoon as well as a more realistic cartoon. And in fact, some of the more realistic cartoons hit me with so much information that I sometimes miss the main purpose. So I really like your idea about the simple, as long as the simple is directed towards the objective of of what the user's trying to do.
That's cool.
Because it's too much realistic information, making it more realistic actually inhibits the thought process. It distracts it. Anyways, that's my experience.
I would agree.
And the question though that I do have is on the powering of the glasses. I'm surprised that we don't have a technology that we can real time um, charge the glasses while you're wearing them. In other words, we can put an iPhone on a base and it will charge. Why can't we have someone either through their clothing or sitting on something that will charge the glasses while they're using them?
So I know of some research that would try to repurpose energy that you may exert as you, for example, open doors and things like that, and manually, and then charge maybe by you doing the energy. I'm not sure exactly how this would work. It's kind of like being like your own little hamster in your own spinning wheel as you're like wearing your glasses. I think it would be cool, but I am not aware of anything in that space. And to be honest, I think, is more, maybe there are some people in the room who have a perspective on it. Well, I think it would require more like physics and a better understanding of how we can harvest energy. But I do think it is a very interesting idea if you can harvest friction in some way, let's say that force that you create as you walk or as you run, there might be good potential there. But unfortunately, not aware of anything right now in this space that is publicly available or something I can share.
Oh, my question is, realistically, I guess what would the price point be? Would it be like cost of a phone or cheaper than a phone, more expensive?
Oh yeah, that's interesting, right? So like, okay, so Michael, how much do you want to sell your glasses for? So if I just support this without without the gaze adaptive display that supports full on, then I think we would probably be, well, it depends on how sophisticated that display is, but I think we can produce it for less than $1,000. We could produce these glasses potentially. I mean, in fact, there are some glasses on the market that have monocular AR. What you cannot buy right now, as far as I know, is like this package that has the cameras, the speakers directed to the temples, and the visual display. You will see glasses with a visual display, but no tracking capabilities, so therefore no camera. Sometimes speakers are missing. So just the Meta Aria research prototype is a very interesting. It's a research device. It doesn't have the right mission statement. It is basically a data collection device. It's cool for research, so you can collect egocentric data. It doesn't offer any real value to the user other than taking pictures of everything you do on a constant basis. But I don't think a lot of people, maybe if you do like, if you like to do diary studies, then I think it's interesting. But it doesn't really provide value. So to provide value, it needs output like a speaker or a visual display. Let's say the dream glasses are, maybe some of you have seen the Meta Orion Unpacked demo when Boz was like demonstrating them, and he was it was actually binocular, so it was a rendering for each eye. It seemed to have world log rendering. It seemed to have, I'm not sure about the eye tracking, I forgot, but there are rumors that these glasses cost $10,000. So then the question is, yeah, can you bring down the cost? I think primarily, I think it is a materials problem because you also need to really deal with cooling. And he was going on in this video about how they use some kind of special aluminum that they only use when you go to space to somehow control. You guys know this better, probably how the waveguide works and how you doesn't overheat and doesn't get unstable. But like, I don't know. Have some of you experiment with these glasses that are actually using a rather old technique? Basically, you have like screens built into the frame and they project down against 45-degree and kind of like project back against the glass. And so you have like, it feels like you have an optical see-through device. These are actually interesting and potentially, I mean, they're in the $300 to $500 range. When you then add tracking to them, you probably, yeah. And then there's also the issue with the software. Like I think, I'm not sure how you think about hand tracking, but we would probably expect this at this point to get hand tracking as good as what it is like with the Quest these days. And maybe the Apple Vision Pro, but I think some people compared it in favor still of Quest. It's just, there are really sophisticated hand tracking models, but they actually require a lot of sensors. Like a Quest headset actually has a lot of like cameras that go around. The question is, for always on AR, what is the right trade-off? Do we have to do everything with one camera, or can we actually have cameras? I mean, I think I would feel better if I know which direction a camera is pointing. But if you imagine the Meta Orion has 7 cameras, some of them are probably looking at your eyes for eye tracking, but some of them are outward facing. Then it just becomes, I would feel, I don't know. If I came in here and started taking photos of all of you, would you feel comfortable? It's probably okay because I'm a speaker. But I had a student come to class. There was the Pixie came out of this Google camera that you can just take with you and put it here and takes photos. And it was, nobody was ready for it. So I think there's then the other question, and I think about this as well sometimes. So I look in the room, and many of you wear glasses right now. And I think those of you who wear glasses right now probably wear them because it is an assistive device to you. It corrects your vision. Some of us, like my colleague in my PhD, his name is Matthias, he was very funny. We were about to teach, the professor asked us to teach a lecture, and he bought his glasses, but they were fake glasses. Like they didn't actually have any power, he just wanted to look smarter. So he to create authority in the classroom. And so he bought these, and I guess it worked for him. And it just is interesting. But how many of us, so we had an interesting discussion that was more like a lunch or actually within the internal forums of Meta. What does it actually take to create social acceptance of glasses? If you think of many movies in the past, oftentimes the people with glasses are the nerds. They know their shit, but they're, yeah, it's just like if you think of Jurassic Park, Dennis, he had glasses and he destroyed Jurassic Park. But he was a good coder. You don't know the magic word is what he left for Samuel L. Jackson. So it's interesting. Now, if you look at movies like The Island, Sean Bean, he was evil, but damn it, he looked so great with these glasses. If you've seen The Island, that just changes how. So I guess we are working as a society towards, there are also studies that when you walk through a public environment, you wear glasses, and you also display to other people that you actually have a disability, and you wear glasses or headsets or some kind of cameras, it will be fine because you probably need it as an assistive device because you have a disability. It seems like social acceptance is more likely to be higher in these kinds of scenarios. But then imagine we actually can now buy Michael's glasses of the future for $759, and so you all walk around with them. I wonder what kind of environment we will create and how we feel about public spaces and private spaces, because technically we don't actually have any private spaces anymore. So anyway, this is more like an ethical discussion. So where were we in our future of AR? Any questions? Anything else you wanted to discuss? Yeah, we have.
I challenged something from your wishes.
Actually, to be honest, for me, it would be great because the second half of the talk, I feel like this is just self-advertisement and you can read my papers. So I would really like to have this discussion. I don't have to get through the other material. It just feels like I only have chapter 1 and we never got to chapter 2 and chapter 3. But that's cool. Let's have this discussion. I'll come back.
Yeah, this may be a bit nitpicky. So I really like your second point that like it should be user-centric, and that's like I think that's something that a lot of people at work in this engineering space miss. Like you need to design it for the user base.
Okay.
But I think it could contradict the first point as well, looking from like a human vision perspective, right? So we know, like you mentioned that we have very high quality vision. The fovea goes a bit down in the foveola, and the periphery, little color perception, a little everything. It is like it's not a uniform system. Like I think human vision is not a uniform system, and there is many ways you can trick it. Like, we have like a massive blind spot that doesn't need to have any stimulus. We have this like high resolution section where you want to like display things with a lot of resolution. The periphery that doesn't have to do a lot. So actually to like match it to the user, I think you need to use complicated techniques. I'd kind of agree. Like, yes, you want to have it as simple as possible while matching it to the user, but I don't think you want to I think you want to have the human visual experience or whatever sensory experience there is as like a minimum and not go below that. So that's kind of the.
So you're saying, of course, I mean, we can look up some like we can actually put some degrees to the visual field. We know roughly where the visual field starts, but like many of us would probably not even be able to address like the full range. For example, as I mentioned to some of you, I did user studies with like 50 people, and the range of a simulated future AR, so simulated on a Quest Pro, and the participant age ranged from 18 to 63. And I had one participant who just felt like they wanted to discontinue my study. They felt uncomfortable because they were wearing contact lenses. And part of the calibration process in the user study required to figure out where can we put the virtual simulated AR display so that they can still see it in their peripheral vision. And you are right, it's not the same for everybody. If my goal is to really place my little window here, my participants always refer to this little display box or window, it would probably be, you could probably move it further out depending on like how much eye movement you have. You also have some participants had like a lazy eye and like eye movement. So I feel like this is more like this is where I learned a lot today. Just like I'm meeting some of you in optics, I've never interacted with people who work in optics and who study really like the computational, like how can we model human visual perception. So think of this as like the naive vision of an HCI researcher who now feels like I have the solution and I just want to create prototypes of this and see where it breaks. But what I haven't seen in industry is actually that somebody tries this right now. You see a subset of the spectrum, and maybe there are also issues. You probably think about the actual glass technology that we would require. I mean, there's a reason why the HoloLens initially could only address 37 degrees and then later 52 degrees of the visual field. And it's pretty hard. So it is interesting for me we also, of course, have various people that have vision deficiency and that within the full visual field, they have additional gray or black areas, essentially. And so maybe this idea will not be of much value as an assistive technology after all. But yeah, I wished I could show you this study and then try to convince you, how many researchers at the beginning of the talk, they say today, I want you to buy into my vision and convince you. I actually wanted to have a conversation with you about this vision. I think there was another question in the area. Somebody raised their hand, no? Okay, yeah.
Arthur, I guess, had a level question about the user center. This is a tool, and it needs to be calibrated to be useful to whatever the individual user is. So, what is the information that, from among many different sorts of information, that is going to appear in these screens how is that information getting to your glasses? Is it sort of wired connections or, wireless?
Yeah, so right now yeah, so it's interesting, right? So who provides the data? How do we provide that data? Will this be locally managed? Let's say if everybody who comes here as a Voices of XR speaker, we can leave a little virtual signature. Would you have to store it? Would Tesla store it because they store so much other spatial information already? Would you buy the Tesla cloud in the future because you have lots of people that mapped out the world for you? So I don't know. So this is like, I don't know exactly what your area is, but like from a software stack and engineering and database stack, there are definitely things I'm ignoring as well right now.
More on the content side of
Yeah.
what information is getting delivered to the person and how relevant is it and how quickly responsive is that information that is delivered to in these glasses.
Yeah. So I think it depends like what the scenario is, but like you can see lots of concept videos online. I wasn't sure what rights whether I could show you, but the Vladimir, previous person who was an internet meta, has like an interesting concept video where he was prototyping essentially an IoT environment. So you could look at every device in your room and control it with your glasses. You could look at the blinds and do a gesture and they would go up. You could control maybe the temperature mid-air. You would see the information, of course, perfectly relevant information, and would have an interesting interaction technique. So when you, I find these interaction design videos inspiring. I use them in my classes to get people to think about this future. What kind of information we would display to users is very interesting. It's also potentially very dangerous because primarily the vendors in the space they want to sell ads. they do, that's how they make money. And so what kind of useful information, what could you imagine for like a first-time visitor like Michael coming to the University of Rochester? I would imagine there's like, how can I find Yukang's office very easily? How do I get back from the restroom after somebody forgot me here or something like this? So like we can leave little breadcrumbs in the area, like virtual breadcrumbs that I can just walk, like I eat them up as I go back, but they're virtual. So Hansel and Gretchen would be safe with my glasses. But we also don't have a lot of really useful, really meaningful information. I think primarily I would like to see information that is spatially, locally relevant. So there are tasks where you're like, would I watch the news on my glasses? I'm not sure. I probably would prefer a display that like our phones, I think, to consume news. But there are a lot of tasks where, like, for example, wayfinding. I show you one slide. I want to be a little bit of an evil guy. And I wonder how many of you think, I don't think you have game design in your program, but maybe. So when I work with a lot of different students, two types of students take my classes, and they often think about content and the applications they want to create for AR, VR. So what is actually the killer application for AR? And so I always have the students, they have the expectation when they take my AR, VR courses, at the end, they will be able to create something like Pokemon Go. This would be my ultimate goal, Michael. Can I take your class? And then at the end of it, I will be able to see little virtual people all over the world, and I get some money for it when I pick them up, or leaderboard points. And then later in my course, I actually shock them because you can go to Pokemon Go death counter, and you will find that actually about 30 people have died. You could say, coincidentally, by going to areas at night that they maybe shouldn't have gone to, but there was a little Pokemon there and some evil people at the same time. And so this is how most of the deaths happened. But there were studies around, for example, police reports and how the number of crashes increased by a small portion, but statistically significant. There was a collaboration between, I don't think it was here, it might have been Cornell and the police department, basically focusing around Pokemon Go stops. So this is maybe not the type of experience you want to create. But I say sometimes as a designer, you feel like, as a game designer, you feel like everything should be glowing. We need full rendering, super duper battery. And then we can see these little Pokemon Go's. So as a UX designer, I think what I try to instill in my students is more like you're thinking about the tasks that we actually need. For example, wayfinding is a very, very important task. And you think about maybe the minimum augmentations that make it easier for you. And I think one of the things I don't think that everybody can read a map very well. Like many of you will feel probably like you're leading the group all the time when you go to a conference. I tell you, Michael, where the ice cream store is because I can read the map. But it is interesting because the transfer you have to do from a 2D map to a 3D environment is actually hard for some people cognitively. And so having simple visual stimuli like the arrows in the bottom is actually a good kind of AR experience. This is simple. It mixes the 2D display. It creates a translation of 2D to 3D by using spatial information. These arrows can be animated. They would disappear if you go out of view. They feel like they actually enrich the user experience. I think applications like this could be useful in classes, and this is probably the kind of information I would like to see. But I don't think we have a lot of really good examples of like really transformative AR applications, or even, do many of you use VR devices on a regular basis? And what do? Play Beat Saber? Well, that doesn't count. You use it for work. How many of us, so all of you are interested in AR VR, okay? Is that true? Okay. How many of you own AR VR devices personally? All right. How many of you use them on a daily basis? Not for work. What do we think the problem is? Is it the applications? Is it that the technology isn't, like, we are the experts. If we don't eat our own dog food, what do you think? What could make us use them more? I don't know.
Well, sample size is biased.
Well, I would expect, wouldn't you expect that if you go into an environment of mostly adopters, believers in our church of AR and VR, that they would use it more, but they don't. Why? I find it fascinating. It is true for me too.
I mean, you talk about it. I feel like it's something more than just a technology. It's a social aspect of it. It's like there's something we can use together. Maybe we'll use it, but now
It's true.
Yeah.
And then also, if you bring it into an environment where not everybody feels that affinity towards this technology, you're creating a lot of stress. There are people who, for example, take AR VR displays on the airplane. Have you been with somebody on an airplane who starts moving around? Or like, I remember when the Apple Vision Pro came out, you saw all these show-off videos. This is me on a bike with my Vision Pro. This is me in a coffee store. And all these people are gone now. They just wanted to land the first YouTube video at the time. So it is, I don't know. So I think, let me try to end with a really nice message here in this talk. There is one thing that I keep promising to my PhD student. I really wanted to show some of our work. We haven't talked about privacy and security. And I want to show you, because I had so many interesting discussions today with you. Many of you know me feel like Yukang has shared some of my work on prototyping. And I just wanted to instill one idea. And if you teach AR VR courses, I think some of you do. We often, as instructors, so this is different. It's a really fast forward. I need new brain power for 2 minutes. We often think about the interactions that we want to enable our users to do. So what are the tasks we want them to be able to do? So then I think about the modalities I need. As a gesture, voice, touching a screen. And then if they can do this, if we can show in a usability study that they can do this, we are all happy. We will get our Chi paper accepted and we will be happy for the rest of our lives. But nobody actually, when we have this luxury, and many of you probably, how many of you work in privacy and security? Like, how many of you do AR, VR, and work in privacy and security at the same time? Now you feel like you should hire somebody in that space, but it is so. How I find it requires a very different mindset. So my PhD student Shweta Rajaram, who I mentioned here, she really set out and made it her thing to study how we can make AR, VR, actually primarily AR, how we can make it safer. And so I just wanted to, I know some of you asked me about some of the prototyping tools that we built and whether you could use it. And this is one where I think we have given it to some people. Actually, I want to show you, it's called Reframe. And so this was a WIS paper, I think 2023. And I just wanted to show you, so it's basically a storyboarding tool. So it doesn't generate any code. It doesn't generate anything else. But as you experience a storyboard, which is here, it's kind of like in 2.5D almost, it inserts little characters that you have never thought about that are actually malicious attackers, like an eavesdropper, a gesture hijacker. So we created this tool to primarily support storyboarding. And so you have like, I think we're going through this a little bit. Maybe it's not as clear on this display, but we basically have like a storyboarding, authoring tool set, and then we have analysis tools that are like displayed on the right. And I think if I listen to Shweta's voice right now, she would probably walk us through all these different components. And then you choose the interactions, but you don't necessarily really sketch them out. And our tool allows you to preview this experience in a kind of like simulated head-worn, mid-air style. And you can actually walk through this scene. It was a little bit inspired by Mental Canvas. As some of you know, Mental Canvas is a very interesting kind of like endless zoom and design tool. And so you can actually preview a storyboard, actually creating a storyboard in a relatively low resolution. What I mean by low resolution is not the pixels, but like the detail with which you express the ideas. And then the coolest, okay, so this is like building kind of like an experience and thinking of the different keyframes and like what are the interactions you can do, like scanning a QR code, and then previewing it. Let's say you have storyboarded it, you can just preview it and then you can be happy. But then you can also have the system challenge you by running it with like an analysis mode. And you can do this yourself if you are familiar with threat modeling. You can choose some of these characters and implement them yourself. Or you can actually have like the system kind of like insert a gesture hijacker, which is very simple. There's no identity built into this gesture. I can always raise a hand in front of your headset and I can trick your headset because there is no fingerprinting or anything involved. So a gesture hijacker is actually a real threat. If we were to use AR glasses in the future, it could be accidental, could be intentional. And so as a storyboarding tool, it just challenges you by inserting some of these characters. And what you would do then is you would realize that as a designer, initially you think multi-model is the way to go. The more modalities, the better. It creates alternative modes of interaction. It will support all kinds of use cases. But what you have actually done by supporting multi-model is you have significantly increased the number of threats I can throw at your AR/VR experience. And so this is a passion of mine to also think about instilling, making designers better at what they do would have probably been one of my goals for the past few years. And one way to do this is to enable design and actually challenge designers as they think about their experiences. So I show you my little slide here at the end. I actually wondered whether any of you had any wishes. So we talked a little bit about whether I got it right, but is something missing? Do you have like a wish? Maybe I could make it true. Michael, the fairy tale. If you had 3 wishes, what would they be? Would you have agreed with what I said here? Partially, or would you have a very different?
Not have OP and affordability of it.
So you want the headsets to be lighter?
Yeah, I want them to look like actual regular glasses.
Yes.
Yeah.
Absolutely.
Okay. Okay. I'll see what we can do by Christmas. But would you be okay to be able to do less than you can, for example, do with a HoloLens? Or
For sure.
Yeah. Okay. But we have to figure out what are the right trade-offs. Jen?
So it seems like in the vision that you laid out, this future of AR, we're going to, like, it's kind of like a wearable device that we have our most time during the day with.
I think so, yes.
Yeah. Have you thought about the impact with human system, the way we perceive and our cognitive system work?
Well, to be honest, I have thought about this. Well, so I guess I should say a lot, but to be honest, I think it's maybe not a lot. But if I use the peripheral vision as a display channel, would I actually make it safer or not safer for users? Because one of the ways we use peripheral vision is we actually see animals chasing us or cars arriving towards us. And there could be good reasons why you should argue that the peripheral vision should never be augmented. It should always be the one channel that keeps users safe. And so I was struggling a little bit with this, whether it's actually a good idea to address peripheral vision with virtual content, because it can actually, yeah, I guess I would also then have a Michael death counter one day. Yeah, it could happen. It can happen to the best designers, I think.
Could possibly just retrain our neurons in our brain that just
over long-term use.
Yeah.
Maybe there will be medical studies. This device is not ADA approved, Michael. It is interesting.
Yeah. Will that make us lazier of thinking?
The Dolly effect, we'll all be dumb babies floating around. I think this is more likely to happen with what you guys do in AI than what I do in AR. But I think also these two are very married. Like the Ray-Ban becoming more and more powerful without actually changing any of the display it has only audio display characteristics, but by improving how you can interact with the device. So it used to be very specific prompt driven. Now you can have a more conversation with it. The LLM is much more trained for short answers. You know how when you ask like ChatGPT and it yells an essay back at you and you're like, oh, I was just asking. I was playing StarCraft. This is a competitive real-time game. I was asking, okay, so what's my opponent's race? It could tell it, most of the time it got it right. What kind of strategy are they playing? And it got that information, it analyzed it. There was a lot of hallucination, but it was still interesting. And it gave very short and precise answers, which I think is actually really interesting. So one of the last thing I have learned, the blind and low vision community seems to be really, really excited about wearable AI. Like scenarios of holding up like 2 bottles of can and ask which one is the Diet Coke and which one is the regular Coke, which I don't know. You cannot. They have the same shape. They are not marked any differently. They look visually the same. They tangibly feel the same. It's a good use case, and it creates autonomy of an agency for users. I don't have to ask Yukon which one is the right. I can decide this with my little wearable friend, my AI. Anyway, yeah.
I have a relevant question about that.
Yeah.
Just the scenario you just mentioned. I feel like you are trying to address a lot of needs from the technology side. But what about, can we rely more on humans? Like, for example, for navigation, if someone is more willing to offer the help to let me know where I should go, then maybe I can get rid of my phone.
So I like that a lot. It relates to a project we have coming up at Kai. So it's a great moment for self-advertisement. We have this concept of privacy-driven adaptations. So many of you probably know context-aware adaptation of interfaces. It's often workload-based, but the idea of privacy-driven adaptation of an AR headset is something that I think resonated well with the reviewers. We are very excited about it. So the idea is if you have a wayfinding AR application and you're going through environments where maybe people would be sensitive to you capturing it, to you running SLAM, to the display figuring out where to go, you could reduce the level of autonomous support and rely on the user skill to maybe remember roughly where they were supposed to be going or show them a map that roughly matches the location. So you kind of like throwing some of the effort back to the user. It requires a world where not everybody is dumb and can use it. I made this mistake when I moved to Ann Arbor in the first year. I was always driving around with Google Maps and I never learned where anything is in Ann Arbor. So then I turned it off and now I feel like becoming a little more of an expert. So this idea of, throwing it back at the user to reduce sensing requirements is something we've experimented with and I think is very, very promising. So even if you can do it in an environment where people maybe feel safe, the context can change very quickly. Like suddenly a new group of users comes into this room because Michael's talk is over now. Maybe we can adapt the interface, and maybe we can reduce the sensors that we use over the next 40 minutes or something like that. So yeah, it's a cool idea. Yeah.
I think mobility, make them colors,
Say again,
customize like different colors.
of the frame?
Yeah.
You're still thinking about the wishes? Okay. Okay, I will write that down. Yeah. We'll see what Santa can do. I do think it is primarily also a fashion device. I mean, I think there are technical reasons why these glasses look like so much fatter. You actually have to get the speakers and technology in here. You have to power the camera, but I think so. Color wouldn't be a problem, I guess. I think most people would want lighter than 50. This is 22. I can really 48, 20. It's really a big difference. The other thing is, I know when somebody with Ray-Ban walks into the room, most people will not pay attention to that. So if everything looks like this, okay, if we live in a future where we can assume that everybody uses this technology, then maybe it doesn't matter. Maybe we will not have to discriminate. But I'll leave you with one last story. We were at Kai in Glasgow in 2018. We were doing a social VR acceptance workshop. It was fun. We were having fun the whole day. And we went out with a Quest device that was powered up. We went out into the public. We just put it on, and we would just see, you know, what research nerds do. We would want to see how the public reacts to this device. And I remember very specifically, it was like going downhill a little bit, and there was a mother coming, and her child was like running towards my collaborator who had the glasses on. And this mother was like, "Jeremy, come here." Because mother has detected that there is something that seems unfamiliar, potentially, like maybe they're recording. I don't want them to record my child. The device was off, but just like it looked like this person was from space. I mean, why is there somebody with a big headset in public? And so the other thing that I think we will need to do, and this is why I like your idea of changing colors and making things lightweight, is maybe by reducing the form factor, we can also create more acceptance, but also at the same time, more vulnerability of our public users. So now I have gone over time. Thank you for having me.
Thanks everybody for attending to this talk. I really enjoyed it. There are something to just keep you in mind is if you would like to continue following Michael's work, their contact info is in the chat. And also please check out the rest of the Voice of XR speaker series and also the recording of the previous talk on the Studio X website. Links are also in the chat. Let's thank Michael again.
Thank you all.
I really enjoyed it, but
It was like